Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem from LeetCode 3633 earliest finish time for land and water rights 1. I will be discussed the both of parts water rights 1 and second part also. The main difference in both part is only constraints. In first problem, the constraint only goes up to 100, size of the both array can goes up to 100, but in the next constraint, the size of the array can goes up to 5 into 10 raised to the power 4. So the main difference for this first and second is only for constraint, which makes this easy problem to medium problem when the constraint becomes very big. So let's discuss the this part first, the and where n comma m is lesser than equal to 100. It is very easily handled using brute force method, where I will be, let's read the problem first. You are given two categories of theme park attraction: land rides and water rides. Land rides, land start time I, earliest time the ith land ride can be boarded. Land duration I, how long ith land ride last. It means that if land start time is 3 and land duration time is 5, then you can start with 3 and you can go to 3 plus 5, that is 8. So the duration of the ride can be 3 comma 8 if you start at 3. If you start at 4, then the duration of ride will be 4 comma 5, 4 plus 5, that is 9. I hope you got this. What is the meaning of land start time? The earliest time the ith ride can be boarded, and land duration, how long the ith land ride lasts. Similarly, water rides also, water start time denotes the earliest time the jth water ride can be boarded, and water duration, how long the jth water ride lasts. A tourist must experience exactly one ride from each category in either order. It means tourists want to take a ride of water and land. There are two possible order. Either he take land to water ride, or he take water to land ride. There are two possible order of riding. A ride may be started at its opening time or any later moment. If a ride is started at time t, it finishes t plus duration, as I discussed here also. Immediately after finishing one ride, tourist may board the other if it is already open, or wait until it opens. It means that let's say the ride will be, land start time is 3 and land duration time is 5, and the water start time is 4 and water duration is 3. So as you can see, land start from 3 and water start from 4, and when the land start from 3 it goes up to 8, and when the water start from 4 it goes up to 7. I hope you got this. 4 plus 3 is 7. So as you can see here, the when you complete the land ride, the water ride is already started at 4 time. But so in this case you don't have to wait any extra time. You can start from 3 to 8, and then 8 to 8 plus duration of the water, that is 3, that is 11. You can finish this land ride and this water ride in 11 ending time. This is the ending time of both ride when you perform land to water. But what happen if water start time is, let's say, 10, and water duration is same as above. So in this case, When you start from 3 and goes up to 8, and then you have to wait for 2 minutes because the water ride is not started yet, so you have to wait for 2 minutes because ride start from 10 to 13. 10 plus 3 is 13, so this is the waiting period. So this question, it says this only, that immediately after finishing one ride, the tourist may board the other if it is already open. Like in this case, it is already open, or wait until it opens. Like in this case, here it is waiting for 2 minutes to get the ride of the water. I hope you get this statement. You have to return the earliest possible time at which tourist can finish both rides. So the main objective is you want to take one ride of water and one ride of land in earliest possible time. The ride order can be anything. The order doesn't matter. The thing that is important to us is earliest possible time. I hope you got this question. You want to take a ride of land and water, either any order, but the possible earliest possible time. You want to minimize the time taken to take the ride of water and land both. I hope you got this. Let's see the brute force method now. What is brute force method? Let's see. In brute force method, you can check all pairs of water and land rights, and the you have to return the minimum of all of those pair. This is a brute force method, and the complexity of this approach is O of m into n, where m is the size of the water and n is the size of the land. So I hope you got this. When you check all pairs of water and land, then you can easily find the minimum of all of those pairs, which one will give you the earliest possible time. Let's see how can you check it. Let's take this as our test case. So for 0 to n, where n is the land size, you go to 0 to m, where m is the water size. So it can be possible that when there are two cases also. Case 1 is land to water, and case 2 is water to land. I will discuss only land to water, then you symmetrically apply this same logic on water to land also. And you have to minimize your answer with minimum of case 1 and case 2. I hope you got this. Let's see land to water approach. uh, Land to water approach, it might be possible that land start time is here. I suppose it as ls, and land end time is le, and water start time is ws, and end time is we. Here as you can see that the land start time and the land end time overlaps with the water start time and water end time. So there is no wait. There is no wait. How can you define it mathematically? So you can easily define it mathematically that whenever ls, that is start time plus duration of land, so I simply make it l of duration is greater than w of s, then it is overlapping, so it denotes that there is no wait. I hope you got this. But when ls plus l duration is here, l duration is nothing but the value of le minus ls. As questions specified only l duration, so le is not the thing, l duration is given to you only, not le. So l of l s plus l duration is lesser than ws, like in this case ls is here and le is here, and ws water start time is here and water end time is here, then you have to wait this much time. So how much time? So in this case there is no overlapping, so you have to wait. So you have to wait. Then how much time you have to wait? Let's see. The wait time is nothing but you have to wait from uh, ws minus ls plus l duration. I hope you got this. You have to wait ws minus, because ls will give you ls plus l duration will give you le. I hope you got this. That's why ws minus le or ws minus ls plus l duration will give you the waiting time. This is waiting time. After waiting time, in this case the wait time is 0, and in this case the wait time is ws minus ls plus duration, l duration. I hope you got this. Then what you will do after waiting, you have to add w duration, which is the duration taken to complete the ride of water. So I hope you got this. How can you handle overlapping and non-overlapping intervals, and if the intervals are overlapping, then there is no wait, the wait is 0, and if it is not overlapping, then you have to wait this much time, and after waiting or non-waiting, then you add simply w duration to your end time of the land. This is the case of land to water. Simply you can apply the same to the water to land also symmetrically. Let's see the code now. Here is the clear java code. Let's discuss it. Here I initialize n variable to land start time dot length denotes the length of the land rights, and the length of the water rights denotes m. Similarly, I initialize mini to integer dot max value, which I will minimize at every step whenever possible. Then I loop from 0 to n and 0 to m. This is nested loop which will take the complexity of O of n m into n. Then I consider the case land to water. In this I initialize the variable end1 to the land start time I plus land duration I. This is equivalent to L of E, as I discussed above. And if the water start time is greater than the LE, that is land start time plus land duration time, then you have to wait some amount of time. The wait time is water start time minus end one, and you simply add end one plus equal to wait plus water duration j. If the wait is 0, then you have to not wait, but here the wait is something positive, So you have to wait this amount of time, then you can enjoy your water ride in water duration j time. If this is case where the interval are non overlapping, but what happen when the interval are overlapping, then you have not to anything wait, the waiting time is 0. So you simply add the water duration time to your end one, and this is your final answer of end one, where the end one denotes the ending time of completing water land, then water land to water time completion, denoted by this and one variable. And similarly in this case, and two variable will denote the water to land ride completion for every pair. And which one is minimum, you take this and minimizes with the global mini, and after that you will simply return your mini as your answer. I hope you got this code. If you are still here, please like and subscribe my video. Then I will discuss the next approach of this problem. As you can see in the above code, the complexity is O of m into n, because this complexity is available, and accepted solution will accept the solution, because here the m and n is lesser than equal to 100. So if you do the complexity of m into n, it goes up only up to 10 raised to the power 4 operations, so it is acceptable. But what happen if m comma n is lesser than equal to 10 raised to the power 4? Does it acceptable? No, because m into m will give you the complexity of 10 raised to the power 8 operations, which is not bearable. So in this case you have to optimize your code little bit. The code will be optimized with a simple observation to this problem, which makes the code of equal to m plus n complexity. Let's see that observation. The observation is, for each case there are two cases only. There are two cases only. What are those cases? Either you go from water to land, or you go from land to water. Let's discuss the water to land case. Then this symmetrically case will apply to the land to water also. Water to land, let's discuss water to land. Then this case is similarly applied to land to water also. Let's see water to land. If you are enjoying your ride and want to take water ride first, then what do you want? My question to you, what do you want? What do you want with water ride time? So the answer to this question is, we want to finish our water ride as early as possible. As early as possible. Why? As early as possible, so that we can enjoy land ride in lesser time. I hope you got this observation. So you have to find the minimum of all those water rides, minimum ending time of all those water rides. So what is the uh, solution to this? Find the minimum time of minimum ending time of all water rides. How you got this? For ending time WE is equal to WS plus W duration. So after adding all WS and W duration, you will take the minimum of all those. Take minimum of all WEs in water array. I hope you got this. After taking the minimum ending time of all water rides, you have a specific ride ending time. Then uh, then you proceed with that ending time to all land. Then proceed with this WE optimal. It means the minimum ending time of water to all land rides and return the minimum ending ending time to complete both complete both rides. I hope you got this. This is similarly applied to land to water also. So I will not explain land to water case. I will only explain water to land case. Land to water is similar to this also. So I hope you got this. This will take you the O of M complexity, where M is the size of water, and this will cost you O of N complexity, where the N is the size of land. So first time you do O of M and next time you do O of N, then the overall complexity for this approach is O of M plus N. Let's discuss its code now, because it is similar to above. So it is the extension problem of the above problem. So no need to discuss more uh, more about it. Let's discuss to code. Here the N is the land length and the M is the water right length, and I early end is denoting the minimum time to end land right out of all land rights. Whenever possible, I will minimize early land. Then I will traverse from 0 to n. As I discussed, n is the land dot length, so I will process all land array and I will minimize my early land to early land comma land start time I plus land duration I, as I discussed in the above intuition. Then end one is one is denoting the minimum time to complete both ride. If you do land to water case. So in land to water case, end one is denoting the minimum time to complete both ride. Let's discuss it. End one, if let's initialize our weight to 0. Whenever there is overlapping interval, I will initialize my weight to something positive, and if it is not overlapping, then the weight is already 0. So simply it will not add it to the early land. If it is positive, then it is added to the early land, and out of all those cases, out of all water rights, out of all water rights, I will take the minimum of all those. Whenever possible, I will minimizes my end one variable with early land plus weight plus water duration I, because this is similar to the above intuition, where above brute force intuition. Similarly, water to land also the same thing is applied as here also. So this is symmetrically applied here also. So out of both possibility, return the minimum of end 1 and end 2. Out of both possibility, what are those possibility? The possibility are water to land and land to water. Land to water is stored in the end 1 and water to land is stored in end 2. Out of both end 1 and end 2, which one is minimum is your answer. I hope you got my code. Please like and subscribe my channel. Thank you for watching my video.